Don Paul, through his expertise, but also because his exceptional scientific curiosity, has been present on all the major active tectonic in the world. He thus worked all around the Mediterranean basin, Algeria, Italy, Lebanon, Syria, but also North America, and but also on the observatory mission in Antilles. However, his true obsession as a researcher, since his thesis in 1978, has remained the tectonics of Asia and the mystery of the Tibetan plateau. Paul was the driving force of the saga of the Franco-Chinese geological collaboration in Tibet since 1980 to 2025, to which I will limit this presentation. 1971, all the story began with the arrival of Montpellier as assistant of Professor Maurice Matauer. He began by modeling experiments to study riddle strike slip fractures. Here you can see on the university sidewalk, not the good one like in the city, but it was also in the university. So we are photographing some experiment of a riddle. Then 2 years later, to study the rocks mechanics with Professor William Brace at MIT, where he met Peter Molnar. He will defend his PhD in 1978 in Montpellier. Les mécanismes de la déformation intracontinentale, exemple de la tectonique alpine en Asie et en Europe. In fact, all this story began with the discovery of Landsat image at MIT. All began in 1974 in Boston with the discovery of this satellite Landsat imagery and the monstrous seismic faults of the Tibetan plateau. You can see the fault of Altintac in this photo. Our marveling this first fantastic image of the Himalayas by the Challenger shuttle in 1984. Thanks to Paul, we understood that satellite imagery constituted a major advance in understanding global geodynamics and the importance of continental deformation in plate tectonics. The first important document is this fantastic old Chinese topographic map of the Himalayas, which inspired all of Paul's thinking. Paul Tapponnier, in his thesis in 1978 on the tectonics of Asia, understood as soon as he saw them the importance of Landsat satellite imagery for exploring tectonics on a continental scale, which he brilliantly exploited in a series of publications in collaboration with Peter Molnar, 75-81. Thanks to satellite imagery, Paul and Peter show for the first time that Tibet, a vast plateau, the roof of the world, at an average altitude over 4,000 meters, great morphological enigma, is crossed by monstrous seismic range fault over 2,000 kilometers long. They propose this mechanic model of slip lines theories by indentation of rigid plastic Asia by India rigid indenter. It's a true revolution of plate tectonics. They show that the deformation of continents contribute to the global geodynamic balance. Asia deforms around the Indian punch, which advances northward since the collision with Asia at a speed of 5 centimeters per year. Since the collision, we must find 2,500 kilometers of shortening responsible of the tectonics of the Himalayas and Asia. Paul Tapponnier, Maurice Matauer, Claude-Jean Allègre, Peter Molnar, we can say these men who make the Tibet great, geology great. Claude Allègre was a fantastic visionary, taking in advance of a great political opportunity of the opening of China. He decided with his friend, Professor Matauer, to appoint Paul Tapponnier, physicist IPG, to supervise a large Franco-Chinese project on Tibet. Franco-Chinese collaboration in geology began in 1980 with the opening of Chennai by President Deng Xiaoping and the visit of President Valéry Giscard d'Estaing in November 1980. French geology, during a first international expedition to Tibet in 1980, was represented by Maurice Matouer, Claude Allègre, and Guy Aubert, director of EINAG, future INSU. You can see here Beijing gathering of a French and Chinese delegation in Guilin in 1982. You can recognize from the left Paul and Kevin, Michel and Vincent, Professor Matouer, Guy Aubert, Claude Allègre, Alphahin, for the French people. On this photograph also, Guilin in July 82, French delegation with C.J. Allègre and some of famous Chinese geologists, like Professor Chan Cheng-fa at the first plane, and like Professor Xiao Shusheng and Professor Li Tingdong. It is in this context that the group of French research plenipotentiary of ING and Institut de Physique du Globe de Paris, IPGP, inspired by Maurice Matouer and the younger Paul Tapponnier, who had just defended his brilliant thesis, decided to launch a long-term cooperation with the Ministry of Geology in Beijing. A major project of a transverse route in southern Tibet to Himalayas was scheduled for the summer of 1982. The best French specialists interested were contacted to participate in this first expedition, which will take place in 2 waves from August to month of September. The IPGP Paris, CNRS, in the University of Diversity, Montpellier, Paris, Orsay, Rennes, Nantes, Nancy, Clermont-Ferrand, will provide the majority of the troops involved, around 30 participants. Paul Tapponnier will spend an entire year in Beijing to prepare the continuation of the Tibet exploration program with our Chinese colleagues. The first mission will be followed by numerous other multidisciplinary missions, the first one in 1984, and then approximately every 2 years, for more than 20 years until 2005. Several geologists from Montpellier will come in Tibet with Paul. Myself, I was on this mission. You can recognize this Professor Mercier, Professor Matouer, and Paul. I think this is in Hong Kong before to be in Beijing. Famous geologists from Montpellier in Lhasa, Professor Jean-Pierre Burg, Dr. Philippe Matt, and Paul at our arrival in Lhasa. Professor Andrieux, Professor Anton Ling, Professor Matouer, and Paul, I think is there in Beijing and I don't know exactly where. Maurice Matouer, his master, will remain his privileged interlocutor for a long time. This is in Pakistan, on the Silk Road. During long discussion of the program in Beijing, all of us enjoyed and will remember the visit of Beijing monuments with our Chinese colleague. Tiananmen and Mao giant portrait, a Great Wall, Forbidden City, even temple, Ming tombs, such as marvelous cities. A part of a French delegation at the arrival in Lhasa in 1980, and some of the very famous Chinese geologists, you can grasp Professor Prost from Montpellier at the center, and different Chinese very important professor, Li Tingdong, Chan Cheng-fa, Xiao Shusheng. And then the flight to Lhasa. First, our arrival, a little days amazed at 3,800 meter altitude in Lhasa, where we quickly realized that running was strictly off limits. Long discussion with our Chinese colleagues were interspersed with geological visits to the nearby hills to test our geological respiratory endurance. And then visit to the many mysterious temples, starting by the Potala Palace of the Dalai Lama. We make also Temple of Jaikan in Lhasa, where we enjoy to make together the tour with Tibetan pilgrims, in the right sense, of course. fortress of Jiangxi, where we ran up 6 floors. And how much we enjoyed this fantastic landscape of the Himalayas seen for the first time by the European geologists from the Tingri Plateau. This is my preferred photograph of Tibet. We enjoy together numerous salted lakes of Tibetan Plateau, Namshu Lake at the foot of Nanchen Tanglafeng. We rejoice in front of all Langta's Tibetan prayer flags. The Mount Everest, 8,848 meters at Rumbuk Monastery, we went there. In fact, Pelzer and Tapponnier, as soon as 1982, during this research mission, proposed a continental extrusion model, rigid, indentation of layer passivity medium, which is improved by a 2-stage extrusion model along Red River Altintag faults, and which is published in Tapponnier in 1986. The main point was to understand the lithospheric model of the India-Asia collision and the mystery of the high plateau called the Chinese third pole of the world. Several hypotheses on the formation of the Tibetan plateau were formulated in the 1980s. Barzanji and Lee suggest horizontal subduction of Indian lithosphere, Dewey et al. Homogeneous thickening of the crust and lithosphere, Mato air thickening by continental subduction, and Molnar suggests hot lithospheric upwelling. After the major mission of early 1980s, Paul will crisscross Tibet and successively visit with numerous students and collaborators all the major fault lines of Tibet. You have in blue all the mission, more or less, and the different missions accomplished by Paul and his students. The years 19 to 2000 will be devoted by the teams led by Paul Tapponnier and Mrs. Shuzikin of the Ministry of Geology of Beijing to more northern studies on the northern edge of the Tibetan Plateau and the study of the Kunlun Ranges, Kilianchan, bordering the Saidam Desert Basin. Special attention was given to the Altintag and Kunlun Grid faults, long of 2,000 kilometers. As a satellite image of the Kunlun fault, for about 20 years or more, Paul continues with all his students to quantify significant dry slip displacement on the Great Fault of Tibet and to quantify the shortening and elevation of the Tibetan Plateau. He did this fantastic work with the precise study of satellite photo. They constrain the Kunlun fault sinistral slipper rates by measuring and dating offset of terraces, risers, and moraines cut by the fault. Like this is the Kunlun fault. Other example, the Great Altintag active fault corresponds to alluvial fan. I don't know if it's working. Sorry. I have a problem with pointer. Okay. So you can see the satellite imagery and the fault. This is a map, detailed mapping of the previous image. Which allows to reconstruct a precise map of the image satellite. After that, the cross-section interprets as a result of a frontal thrust. Stretching and elevation can be measured with great precision. A more general cross-section allows to determine the quantity of stretching at the front of a Tashuishan, the mountain, more than 20 kilometers for this example, only in the Holocene age. For precise measurements and history of recent faults, Paul used theodolite sighting and trench excavation studies. 1986, Paul is working above vertical mylonitic shear zone on the Afar and Red River fault. We followed together the Karakoram fault, which allows to rise above the Karakul lake of the magnificent Mustagata, 5,546 meters, in Uyghur region of Xinjiang. We went together to Rombok Monastery, Everest Base Camp, where we discovered the gravitational shear zone, now called as South Tibetan Detachment, STD, published by Berg and Brunel. This methodology has been applied to all the major faults of Tibet by calling on numerous collaborators who brought the most modern and diverse dating methods. It was possible to better quantify the displacement and shortening occurring since 54 million years, age of the collision of India. And Paul and then the Dream Team and Sophie, Nicolas, Françoise in the Bat subsided basin in 1994. Along the Karakoram Fault near Mustagata in 1980, Faultman is most often in red sweat. Mustagata, again, climbing below the Karakoram Fault, along Karakoram Normal Fault. And Paul also like a blue color, matching his Uyghur cap. Another year, Paul was on MBT in Nepal in 2007 to 2012. Front of the Tibet Plateau in Shilan Mountain at Great Wall for the Yayurgan in front of Kilian. Paul is here on the Kunlun Fault in 1996. In a colorful language inherited from his master, Maurice Matouer, Paul said, and so it's sinister or dexter. You don't know. Paul and Mrs. Shu, a great complicity and the same desire to advance further and higher. Goldmood in 1994. Further and higher was the motto. Paul and Maurice and Geoffrey on the Kunlun Fault and Kokachidi in 1988. Red coat is required clothing Paul and Nicola in the Altun Chan, 1998. Amaduraim, 6,724 meters in South Tibet, rise under north-south normal fault, where we recognize Paul, Hervé, Robin, Liu, and Jérôme. Once acclimatized to altitude above 4,000 meters, living for working conditions in Tibet were special. Paul always gave a lot of himself. For example, sleeping here outside at 4,200 meters in a camel's park. Or pushing here the truck stuck in the mud at an altitude of 4,550 meters in the Kokchili Plateau. Or pulling a barge to cross a river in Vietnam. Filled with Uyghur or Tibetan yogurt, we ate the entire contents of this magnificent popular pot. Just the two of us was super unusual. Paul searched everywhere for Marco Polo mufflons, all over the Tibetan plateau, and ended up finding the famous Mat Polo specimen. This is Philippe Mat from Montpellier. It was the last time that Paul rode a camel in the desert of Saidam. He was going to fall hard from this camel, in love of a camel in front of him. Paul was also a hard worker, even on a plane. All of the projects over the period 1985 to 2001 will be developed under the direction of Paul Tapponnier and will end with the Kashgar and La Grande Motte Congresses organized by Montpellier in 1995. Then the final Congress in 2000 by the Académie of Science in the Ministry of Geology in Beijing. Paul presented here this final model of public stepwise rise and growth of the Tibetan plateau. Nearly 200 participants attended this Congress in Kashgar in 1982 or in Beijing in 2000. At the end, Paul Tapponnier from 2008 will be visiting professor at NTU University in Singapore. Paul received here Oxford Medal from AUGAS in June 2018 in Hawaii. A future success to the story. Paul surrounded by 4 of his best former students, Laurent Bollinger, Yann Klinger, Jiao King, Jean-Philippe Awak. Paul congratulated by his friend Satish Singh here in the room. In the final years, before his premature death, Paul Tapponnier was unable to participate in high-altitude mission. In 2019, he moved to the National Institute of Natural Hazard in Beijing, where he continued to create extraordinary scientific emulation. He nurtured a new generation of young researchers to carry forward his passion for geology, geomorphology, and tectonics of Asia. Paul's legacy is also assured in Beijing. You can see the young people around them. Kanbei, Paul. With the Professor Xu Ziqin, his friend from the beginning, he took part in the Nanjing Congress in May 2023, where he presented the final development of his Asia deformation model. Paul's legacy in the final is the model of 2023 with Jiao King. Paul proposed a model with 3 massive faults, 4,000 kilometers long, Altintag, Red River, and Sagaing Fault, to explain extrusion of a block, Tibet, and Sundaland eastwards. In this talk in Nanjing, he shows that the extrusion model is consistent with large tertiary active faults. This is the map of the simplified map of a prominent tertiary and active fault. Red for strike slip and yellow for thrust. I think this map will be, for the future, will be very important. This new model of discrete element DEM allows to simulate the share of lithospheric shortening, the animation of a lithospheric deformation in section, the position of earthquakes, the displacement vectors, the paleolatitude, and the declinations. This is the last paper in 2023. Fantastic. The penetration of the Indian indenture into the Asian plate consecutively generates 4 main mountain ranges in Tibet and is in agreement with the progressive construction of the Tibetan plateau by the formation of 4 successive ranges. The first one, Bangong, from the south to the north, Bangong, then Tangula, then Kulnun, and in final Kilianchan. By southward continental subduction, 1, 2, 3, 4. Erosion debris are retained in 4 successive basins, Shantung, to the south, Toto, Songpan, Saidam, that young northward away from the Indian indenture. The crust, thus redoubled below Tibet, can take into account a cumulative shortening of 1,250 kilometers, or half of the India-Asia convergence since 50 million years. I think this figure is the legacy of Paul. The collaboration of Chinese at IPG Paris, paleomagnetism teams provided the fundamental data to initiate and constrain the extrusion model. Look, say Vincent, that's Paul draws. It's exactly what you were see here. It's fantastic. As a conclusion of life's work, Paul offers a definitive model and laws of Tibet building. The Tibetan lithosphere is strong and not weak. Tibet is an orogen which retains its erosion debris. The crust is thickened, but not the mantle. A type of plate tectonics operates under the thickened crust. It is the propagation of a great lithospheric range fault which orchestrates the growth of Tibet with oblique subduction of mantle lithosphere along them. The DEM model results provide insight into fault birth, propagation, and motion, as well as mountain building and plateau growth. They corroborate that continental crust thickening across Tibet alternated with extrusion of large blocks that rifted apart eastward in the far field. Kevin and Paul, a solar couple, still together on this adventure. She published the best photo of landscapes and people of Tibet in different wonderful books. The best one, Mountains, written with Paul, a unique book, in my opinion, to understand and teach how mountains live. So, again, in my opinion, probably Paul will be remembered as the last of the great explorers of Asia, following in the footsteps of his favorite heroes, so often referenced by him: Alexander David-Nel, Marco Polo, of course, Zinedine, Émile Argan, and Augusto Ganser. Bye-bye, Paul. We'll never forget you. For myself, this Tibetan saga was the chance of a lifetime, and I would like to thank Paul for leading us. Myself, his students and collaborators are proud and grateful to have followed him on this fantastic adventure. Thanks so much, Paul. You're still alive. Forever in our minds. Thank you very much for your attention.